Okay, welcome to today's lesson. We are looking at partial fractions. So the question that we have right there says resolve into partial fractions 5x minus 3 divided by x squared minus 3x minus 4. So when you talk of partial fractions, we are simply talking about a fraction that is expressed into parts. Okay, so now what we are mainly interested, for example, in this question, we are mainly interested at the denominator. We need to find a way in which we are going to break down this denominator into linear functions. Alright, so the only way that we can do this is by applying the factorization method. Alright, so the question goes like this. This will be 5x minus 3. We've just copied the way it is, then divided by. So we are breaking this into linear factors using the factorization method because this is a quadratic equation. So now quadratic equation can be solved either using the formula method, the completing the square method, or the factorization method. Then for this particular question, we are going to use the factorization method to solve it. So we'll have our denominator changing. This will give us x minus 4, and then we'll have x plus 1. Alright, so we've simply changed this into that. So now this will just be equal to, we now separate the two, okay, because we are talking of partial, so meaning that parts of fractions. So we need to express it as the parts of this whole thing here. So we'll have x minus 4 like that in brackets, okay, then we say plus, we have this, then x plus 1. Now you might be wondering why I've not written anything here on the numerators. I've only written down the denominators. Okay, the reason is simple. So now whenever you're expressing partial fractions, we're talking about linear, okay, linear factors. So this is partial fractions involving linear factors. So now what it is the numerator should always have a degree that is less than that of a denominator. So now if you check on this, the both of these, you will find that the degree of x is just 1, even here is 1. So whatever we have on top should have a degree less than that of a numerator. So since the degree is 1 and here the degree is 1, the only way that the degree of the numerator can be less than that of the denominator is when you have a constant. So in this case, we'll say we'll put a here for the meantime, and then we'll put b. So this is just a over x minus 4 plus b over x plus 1. So these two letters that we are seeing here, a and b, are standing in for the constant, because when you put a constant here, it will have a degree that is less than that of the denominator. Okay, so now how do we resolve this into partial fractions? Okay, let me write this one here. This is just a 5x minus 3 over x minus 4 like that, then x plus 1, which is just equal to a over x minus 4 plus a b over x plus 1 in brackets like that. So now at this stage we must get rid of the denominators. So the only way we can do that is by multiplying with the common denominator, which is just x minus 4, then x plus 1 like that. So when we multiply this with everything here, you find that this and this will cancel out. So this will just be equal to 5x minus 3, which is equal to, and then this multiplied by this, the x minus 4 cancel out, and the x minus 4, then we'll have x plus 1 multiplied by the a. So we'll have a times x plus 1 like that. And plus we'll have a b multiplied by the opposite, which is x minus 4 like that. Now we are done. What we are remaining with is the numerators only. The denominators are gone. So now what do we do with this one? Remember, we are looking for the values of a and b. So for this one, we can just say there are two ways in which we can solve this. Okay, so now be on the lookout for the for another method in our next example. So for this particular one, we'll use this method. We can say we want to find the value of b, so we must let x to be equal to -1, so that when you put -1 here, we'll get a 0, and then 0 times a will just give you a 0, and then we calculate for the value of b. So what we have here is a 0, so this will just be equal to 5. Where there's x, I'm replacing with a -1 because I've let x to be equal to -1 minus 3, which is equal to a, open brackets, you have a -1 plus 1 like that, then a plus c, a b, in brackets you have where there's x, -1 minus 4, like that. So now 5 times -1, we're doing the calculations. 5 times -1 will give us a -5. -5 minus 3 will give us a -8, which is just equal to a -1 plus 1 in brackets will have a 0. 0 times a, that is just a 0, meaning that this part is gone. So we are remaining with this part, -1 minus 4, that will give us a -5. -5 times b will give us a -5b. We are looking for the value of b, so we divide both sides by a -5, like that, so that this can cancel out. Then you have the value of b being equal to the negative, and the negative cancel out. You have the value of b being equal to 80/5, like that. So we can do the same procedure then for the next one, where we say we can let x to be equal to +4, so that it will be 4 minus 4. All you want is to have a 0, so that we can only remain with one letter and then solve for it. So this will just be, I'll write this again, you have a 5, where there is x, this time around you are letting x to be equal to +4, so 4 minus 3, which is equal to a, where there is x, we're putting 4 plus 1, like that, then plus a b, in brackets you have a +4 minus 4, that will just give you a 0, so meaning that the b is gone. Okay, we've eliminated the b in that way. Then you have a 5 times 4, which is a 20. 20 minus 3, that is a 17, which is equal to, where there's a, so this will be 4 plus 1, that is a 5. 5 times a, you have a 5a. This is a 0 this side. We're looking for the value of a, we divide both sides by a 5, even this side by a 5. You have the value of a, this and this will cancel out, your value of a being equal to 17/5. Now these are the two values of a and b. So now we get back to this part here and do this part here and do the replacements. So the original equation now, after working out those constants, we have a 5x minus 3, everything divided by x minus 4, like that. Then you have x plus 1, which is just equal to a, we have a 17/5 divided by x minus 4, like that, plus we have the value of b being equal to 8/5 divided by x plus 1 in brackets, like that. So now if you check now, the degree of the numerator is less than the degree of the denominator. So this is how you resolve such questions into partial fractions. See you in another class. Be on the lookout. Thank you.